Throughout this course, you will explore topics with Maria. Maria is a new hire at an APN partner company.
Hi, I'm Maria. I just started my new job as a solutions architect. I work in pre-sales engagements to provide architectural help with projects and design needs. I also provide technical advice and work with customers to set architectural direction. My background is in on-premises traditional IT. I plan to use my skills to advise customers on their cloud journey, but I want to improve my AWS cloud knowledge and skills so I can provide the best value to our customers. This course is an excellent starting point for me. It introduces core AWS technologies and shows me how to apply them to build customer solutions. It also covers best practices and APN partner community resources. I'm ready to get started. I've got a meeting coming up with my customer, Any Company Apparel. And I'll admit, my knowledge of the cloud and AWS technology is lacking. I really need to brush up on the basics of cloud technology and what AWS has to offer before I meet with my customer next week.
What is cloud? In a traditional on-premises IT environment, all the physical components required to run business systems were owned, operated, maintained, and housed by the company. A user would connect and log on to the corporate network and access resources that way. This would include corporate applications, file sharing, storage, etc. The cloud provides access to the same or similar resources through the Internet, as hosted by a cloud services platform. The term itself comes from a time when Internet resources or connectivity was often represented by a cloud in diagrams that illustrated connectivity and data flow. What is cloud computing? Cloud computing is the on-demand delivery of compute power, database, storage, applications, and other IT resources through a cloud services platform via the Internet with pay-as-you-go pricing. A cloud services platform, such as Amazon Web Services, owns and maintains the network-connected hardware required for these application services, while customers provision and use what they need via a web application. So, what makes cloud computing an attractive IT solution to customers? Some of the benefits of cloud computing compared to traditional on-premises IT infrastructure are the following. Agility. The cloud provides easy access to a broad range of technologies, so organizations can innovate faster and build nearly anything they can imagine. Organizations can quickly spin up resources as they need them, from infrastructure services such as compute, storage, and databases, to Internet of Things, machine learning, data lakes and analytics, and much more. An organization can deploy technology services in a matter of minutes and get from an idea to implementation much faster than before. This allows an organization the freedom to experiment, test new ideas to differentiate customer experiences, and transform their business. Elasticity. With cloud computing, there is no need to over-provision resources up front to handle peak levels of business activity in the future. Instead, resources can be provisioned with the amount of resources that are actually needed. The resources can then be scaled up or down to instantly grow and shrink capacity as business needs change. Cost savings. The cloud allows an organization to trade capital expenses, such as data centers and physical servers, for variable expenses, and only pay for IT as they consume it. Plus, the variable expenses are much lower due to the economies of scale. Deploy globally in minutes. With the cloud, organizations can expand to new geographic regions and deploy globally in minutes. For example, AWS has infrastructure all over the world, so deploying an application in multiple physical locations can be done with just a few clicks. Putting applications in closer proximity to end users reduces latency and improves their experience. How does AWS fit into this? AWS offers a broad portfolio of global cloud-based products, including compute, storage, database, analytics, networking, mobile, development tools, management tools, Internet of Things, security, and enterprise applications that is on demand, available in seconds with pay-as-you-go pricing. From data warehousing to deployment tools, directories to content delivery, new services can be provisioned quickly without the upfront capital expense. This allows enterprises, startups, small and medium businesses, and customers in the public sector to access to the building blocks they need to respond quickly to changing business requirements.
So, the cloud offers on-demand delivery of IT with pay-as-you-go pricing instead of costly upfront investments.
On top of that, AWS offers a huge range of features and services to help customers solve business challenges and achieve their goals. I'd like to learn more about the technology, starting with the infrastructure required to support it.
Amazon's cloud computing resources are hosted in multiple locations worldwide, called AWS regions. Each region is designed to be completely isolated from the other regions. This achieves the greatest possible fault tolerance and stability. When you view your resources, you'll only see the resources tied to the region you've specified. This is because regions are isolated from each other, and we don't replicate resources across regions automatically. Within each region is a separate geographic area that has multiple locations isolated from each other, known as availability zones, or AZs. Each AZ is fully isolated from other AZs within the region. They are many kilometers apart and take into account geographical features such as fault lines for further resiliency. Though physically separate, all AZs within a region are interconnected via high bandwidth, low latency, fully redundant fiber. In the above example, we're looking at the region named AP Southeast 1. Everything within that region is located in Singapore. That region consists of 3 distinct zones referred to as AP Southeast 1A, B, and C. If you were to host a resource in Singapore, hosting it within 2 or more availability zones in that region would provide sufficient high availability in a wide variety of failure scenarios. AWS local zones are a type of infrastructure deployment that places compute, storage, database, and other select AWS services close to large populations and industry centers. AWS Wavelength embeds AWS compute and storage services within 5G networks, providing mobile edge computing infrastructure for developing, deploying, and scaling ultra-low latency applications. AWS Direct Connect is a cloud service that links your network directly to AWS, bypassing the internet to deliver more consistent, lower latency performance. It offers locations worldwide to ensure you can make connections close to where you need them. Amazon CloudFront is a web service that speeds up distribution of your static and dynamic web content to your users. It delivers content to web users through worldwide points of presence in the form of edge locations and regional edge caches.
Wow, that sounds massive. I remember from my on-premises days the expense and challenge of achieving fault tolerance and availability for mission-critical applications, plus making sure international customers had an experience that's similar to customers near their core data centers. The AWS infrastructure has a lot of options here. My next step is to start digging into the services that AWS has to offer.
Compute services allow customers to develop, deploy, run, and scale applications and workloads in the AWS cloud. Here's a look at some of these products. Amazon Elastic Compute Cloud, or Amazon EC2, is a web service that provides secure, resizable compute capacity in the cloud. Compute capacity refers to the functionality that is traditionally provided by on-premises physical or virtual servers. Amazon EC2 offers the broadest and deepest compute platform, with over 400 instances and choice of processor, storage, networking, operating system, and purchase model. With Amazon EC2 autoscaling, customers can maintain the health and availability of their applications by setting triggers to automatically increase or decrease the number of instances in their deployments. Your customers can use a load balancing service called Elastic Load Balancing, or ELB, that automatically distributes incoming application traffic across multiple targets, such as Amazon EC2 instances, containers, IP addresses, and Lambda functions. Amazon EC2 Container Service, or ECS, is a highly scalable, high-performance container management service that supports Docker containers and allows customers to easily run applications on a managed cluster of Amazon EC2 instances or in AWS Fargate. AWS Fargate is a serverless pay-as-you-go compute engine compatible with both Amazon Elastic Container Service and Amazon Elastic Kubernetes Service, or EKS. Amazon EKS is a managed Kubernetes service that makes it easy to run Kubernetes on AWS and on-premises. Amazon EKS allows Kubernetes applications to run on both Amazon EC2 and AWS Fargate. Amazon EKS automatically manages the availability and scalability of the Kubernetes control plane nodes responsible for scheduling containers, managing application availability, storing cluster data, and other key tasks. AWS Lambda is a compute service that runs code without the need to provision or manage servers. It is referred to as serverless computing. AWS Lambda starts running code within milliseconds of an event, such as an image upload, in-app activity, website click, or output from a connected device. What makes Amazon EC2 such a powerful service? Elasticity. Amazon EC2 enables customers to increase or decrease compute capacity within minutes, not hours or days. Combined with Amazon EC2 autoscaling, which you will learn about shortly, Customers maintain availability of their Amazon EC2 fleet and automatically scale up and down depending on their needs in order to maximize performance and minimize cost. Complete control. Customers have complete control of their instances, including root access or administrator access, and the ability to interact with them as they would any machine. Flexible cloud hosting services. Customers have the choice of multiple instance types, operating systems, and software packages. Integrated. Amazon EC2 is integrated with most AWS services to provide a complete, secure solution for computing, query processing, and cloud storage across a wide range of applications. You will learn more about these services in just a few minutes. Reliable. Amazon EC2 offers a highly reliable environment where replacement instances can be rapidly and predictably commissioned. The service runs within Amazon's proven network infrastructure and data centers. Secure. AWS customers benefit from a data center and network architecture built to meet the needs of the most security-sensitive organizations. Cost-effective. Using Amazon EC2 lets customers take advantage of Amazon's scale. It enables customers to pay a very low rate for the compute capacity they actually consume. Easy to get started. AWS is free to get started. Customers can leverage the management console, the command line interface, or SDKs, which you will be introduced to at the end of this module. Amazon EC2 provides a wide selection of hardware and software configurations optimized to fit different use cases. Instance types comprise varying combinations of CPU, memory, storage, and networking capacity to give you the flexibility to choose the appropriate mix of resources for your applications. Instances are first divided into several general categories. General-purpose instances provide a balance of compute, memory, and network resources, and can be used for a variety of diverse workloads. Compute-optimized instances are ideal for compute-bound applications that benefit from high-performance processors. Memory-optimized instances are designed to deliver fast performance for workloads that process large datasets in memory. Accelerated computing instances use hardware accelerators or coprocessors to perform functions such as floating-point number calculations, graphics processing, data pattern matching, more efficiently than is possible in software running on CPUs. Storage-optimized instances are designed for workloads that require high sequential read and write access to very large datasets on local storage. They are optimized to deliver tens of thousands of low-latency random I/O operations per second, or IOPS, to applications. Each category has different families with fundamental differences within the category. For instance, the general-purpose category has 4 families: Mac, A, T, and M. Within each family are different generations, which are slight variations. The T2 generation has the unique features as shown here. Within each generation, each instance type is designated by a size, such as nano, small, extra large, etc. For example, if you select the T2.2x large instance type, your instance will have the balanced performance provided by the general-purpose category, with the features unique to the T2 family and generation. And specifically, it would feature 8 virtual CPUs, 32 gigabytes of memory, and moderate network performance. Here's an example at the higher end. We can see the memory-optimized instance X1E.32x large, with 128 virtual CPUs, nearly 4 terabytes of memory, and high storage and network bandwidth. While the instance type refers to the hardware capabilities of an instance, Amazon Machine Images, or AMIs, refer to the initial software configuration of an instance. When launching an instance for the first time, customers must first specify a source AMI. They can launch multiple instances from a single AMI when multiple instances with the same configuration are needed. Customers can select AMIs provided by AWS, or the AWS Marketplace, or the AWS user community. Customers may also create and maintain their own custom AMIs. In a traditional data center environment, the scalability of a system is bound by the physical hardware. Take the example of a tax preparation business in the United States. U.S. taxpayers must file their taxes by April 15th every year. Online tax preparation companies know that they will experience a steady flow of traffic starting near the middle of January, with the traffic peaking close to the April 15th deadline. In a data center, anticipating this 4-month period of heavy use requires spinning up enough physical servers to handle the anticipated load. But what happens to those servers the rest of the year? They sit idle in the data center. In the cloud, because computing power is a programmatic resource, customers can take a more flexible approach to the issue of scaling. They can program their system to create new EC2 instances in advance of known peak periods in a business cycle, such as tax filing deadlines. However, adding the use of monitoring, customers can programmatically scale out their servers when they notice that critical resources, such as average CPU utilization across their fleet, are becoming constrained. Furthermore, they can automatically scale in the number of resources they use during peak times, when demand for their business services return to their baseline. In other words, they only pay for the resources they need when they need them. What's required to implement such a system? Continue on to see how several AWS services can be used together to create a scalable on-demand architecture. An Amazon EC2 autoscaling group helps you to define where Amazon EC2 autoscaling deploys resources. In an autoscaling group, you specify the Amazon VPC and subnets for your Amazon EC2 instance deployed by Amazon EC2 autoscaling. You must select at least 2 subnets across different availability zones. Autoscaling groups help you choose Amazon EC2 instance types. You can choose on-demand instances, spot instances, or both. The number of instances running in an autoscaling group are controlled by 3 settings: minimum, maximum, and desired capacity. Minimum ensures that you always have a certain number of Amazon EC2 instances running at all times. Maximum lets Amazon EC2 autoscaling scale out the number of Amazon EC2 instances as needed to handle an increase in demand. Desired capacity must be greater than or equal to the minimum limit and less than or equal to the maximum limit. Causing the autoscaling group to launch or terminate instances is like changing the desired capacity. Its value is usually set by an automated process, such as an autoscaling policy, autoscaling event, or a Lambda function, but it can be directly edited in the console where you can observe the effects. Elastic load balancing automatically distributes traffic across multiple EC2 instances to help achieve better fault tolerance and availability. It works by accepting incoming traffic from clients and routes requests to its registered targets, such as EC2 instances, in one or more availability zones in a region. Elastic load balancing increases the availability and fault tolerance of applications. Customers can configure health checks, which monitor the health of the compute resources, so that the load balancer sends requests only to the healthy ones. They can also offload the work of encryption and decryption to the load balancer, so that compute resources can focus on their main work. Customers can select a load balancer based on their application needs. Elastic load balancing supports 3 types of load balancers. Application load balancers are specially designed for web applications with HTTP and HTTPS traffic and operate at the application layer. Network load balancers operate at the network layer and are more resilient to sudden traffic spikes. Gateway load balancers forward traffic to virtual appliances found in AWS Marketplace from third-party vendors.
So EC2 are my compute building blocks on AWS. They come in a huge variety of hardware capabilities to meet the demands of any workload. And I can apply AMIs to customize the software installation when launched. Additionally, I can configure auto-scaling and load balancing so that my application is always running the proper amount of instances based upon the needs of the application at any given time. Whether it's during high demand or low demand, I'm only ever running and paying for exactly what's required. The next thing on my list is to learn about where and how to store my data.
Anytime a server is set up, whether a physical server or a virtual server, there needs to be somewhere to store the data the server will access. AWS has several storage services, including a durable, scalable object store called Amazon Simple Storage Service, or S3, and a block store called Elastic Block Store, or EBS. Amazon EBS is like a hard drive for Amazon EC2 instances. Customers can create partitions on it, format it, and boot their operating systems off it. It provides persistent block-level storage volumes. Amazon S3 is storage for the internet that is designed to make web-scale computing easier for developers. It provides a simple web interface that can be used to store and retrieve any amount of data, at any time, from anywhere on the web. Amazon S3 Glacier is a storage service that provides secure and durable storage for data archiving and backup. It enables organizations to easily and cost-effectively retain data for months, years, or decades. The AWS Storage Gateway is a service providing seamless and secure integration between an organization's on-premises IT environment and the AWS storage infrastructure, so that large amounts of data can be transferred into and out of the AWS cloud. Amazon Elastic File System, or Amazon EFS, is a file storage service. Amazon EFS is easy to use and provides a simple interface for creating and configuring file systems. Storage capacity is elastic and grows or shrinks automatically as files are added and removed. Amazon FSx File Systems is a fully managed file storage built on 4 widely used file systems: NetApp ONTAP, OpenZVS, Windows File Server, and Lustre. The file system selected is typically based on familiarity with a given file system or by matching the file system's feature set, performance profiles, and data management capabilities to the requirements of a workload. Amazon EBS volumes provide durable block-level storage for use with Amazon EC2 instances. EBS volumes are network-attached storage that persist independently from the running life of a single instance. After a volume is attached to an instance, customers can use the volume like a physical hard drive, typically by formatting it with the file system of their choice, and using the File I/O interface provided by the instance operating system. When customers create an EBS volume in an availability zone, it is automatically replicated within that zone to prevent data loss due to failure of any single hardware component. After customers create a volume, they can attach it to any EC2 instance in the same availability zone. An Amazon EBS volume can be attached to only one instance at a time, except in the case of using multi-attach with provisioned IOPS SSD IO1 volume to up to 16 Nitro-based instances. However, multiple volumes can be attached to a single instance. By default, EBS volumes that are attached to a running instance automatically detach from the instance with their data intact when that instance is terminated. The volume can then be reattached to a new instance, enabling quick recovery. EBS also provides the ability to create point-in-time snapshots of volumes, which are stored in S3. These snapshots can be used as the starting point for new EBS volumes and to protect data for long-term durability. The same snapshot can be used to instantiate as many volumes as desired. These snapshots can be copied across AWS regions, making it easier to leverage multiple AWS regions for geographical expansion, data center migration, and disaster recovery. Sizes for Amazon EBS volumes range from 1 GB to 16 TB, depending upon the volume type, and are allocated in 1 GB increments. Amazon S3 is an object storage service. It stores data as objects in resources called buckets. Customers can store as many objects as they want in a bucket, and read, write, and delete objects in their bucket. Objects can be up to 5 TB in size, but there are no limits to the total storage consumed or amount of objects. Amazon S3 is designed to deliver 11 nines of durability, which means that for every 10 million objects stored, customers can expect to incur an average loss of a single object once every 10,000 years. Amazon S3 also provides 4 nines of availability. Common S3 use cases include data lakes hosting. Build a centralized repository to store all structured and unstructured data at any scale to allow big data analytics, artificial intelligence, or AI, machine learning, or ML, and high-performance computing, or HPC, applications can run to unlock data insights. Backup and storage. Provide data backup and storage services for others. Application hosting. Provide services that deploy, install, and manage web applications. Media hosting. Build a redundant, scalable, and highly available infrastructure that hosts video, photo, or music uploads and downloads. Software delivery. Host software applications that customers can download. It is critical to understand the types, volumes, and access characteristics of customer data. With the variety of Amazon S3 storage types available on AWS, choosing the right storage class is an important architectural decision. Even within a single storage service like S3, there are choices. Amazon S3 Standard is intended for frequently accessed data. Because it delivers low latency and high throughput, S3 Standard is appropriate for a wide variety of use cases. Amazon S3 Standard Infrequent Access, or S3 Standard IA, is for data that is accessed less frequently, but requires rapid access when needed. S3 Standard IA is similar to S3 Standard, but with a lower per gigabyte storage price and per gigabyte retrieval fee. It is ideal for long-term storage, backups, and as a data store for disaster recovery files. Amazon S3 OneZone Infrequent Access, S3 OneZone IA, is also for data that is accessed less frequently. Other S3 storage classes store data in a minimum of 3 availability zones, while S3 OneZone IA stores data in a single AZ, resulting in 99.5% availability. It costs less than S3 Standard IA. It is ideal for customers who do not require the availability and resilience of S3 Standard or S3 Standard IA. It is a good choice for storing secondary backup copies of on-premises data or easily recreatable data. Lastly, S3 Glacier is secure, durable, and low-cost storage classes for data archiving. It provides 3 retrieval options: Amazon S3 Instant Retrieval, Amazon S3 Glacier Flexible Retrieval, and Amazon S3 Deep Archive. These options range from a few minutes to hours. It can replace tape for media and entertainment applications, and assist with compliance in highly regulated organizations like healthcare, life sciences, and financial services. Also offered is Amazon S3 Intelligent Tiering, which delivers automatic cost savings by moving data between 2 access tiers, configured by the customer.
Okay, so EBS provides disks for my instances. It was nice to hear that they replicate every EBS volume upon creation. S3 sounds great for bulk storage though, whether it's images, videos, code. The high availability and speed of access sounds great. And the fact that they have different tiers based upon how frequently you need to access it means that I can offer something like Glacier as a cost-effective alternative to things like long-term backup storage. Next on my list is database services. I know you can set up a database by installing and configuring it directly onto an EC2 instance, so I'd like to learn more about what AWS database services have to offer.
AWS offers the broadest range of databases that are purpose-built for specific application use cases. AWS database services handle time-consuming database management tasks such as backup, patch management, and replication, allowing customers to pursue higher-value application development or database refinements. Amazon Relational Database Service, or Amazon RDS, is a managed relational database service with a choice of 6 popular database engines, including Amazon Aurora, PostgreSQL, MySQL, MariaDB, Oracle Database, and SQL Server. Customers can set up, operate, and scale a relational database in the cloud that provides cost-efficient and resizable capacity. Amazon RDS has many other features that enhance reliability for critical production databases, including automated backups, database snapshots, and automatic host replacement. Amazon DynamoDB is a NoSQL database that delivers single-digit millisecond performance at any scale. With a few clicks in the AWS Management Console, customers can launch a new Amazon DynamoDB database table, scale their requested capacity without downtime or performance degradation, and gain visibility into resource usage and performance metrics. Amazon Elasticache is a caching service that makes it easy to deploy, operate, and scale an in-memory cache in the cloud. It improves the performance of web applications by allowing customers to retrieve information from a fast, managed in-memory caching system instead of relying entirely on slower disk-based systems. There are additional database services and features available. Visit aws.amazon.com/databases to learn more about them. Amazon database services are easier to set up, manage, and maintain than running database software on Amazon EC2. They let customers focus on tasks other than the day-to-day administration of the database platform. Alternatively, running their own database software will give them more control, flexibility, and choice. Depending on the customer's application and their requirements, they may prefer one over the other. Here are some of the advantages for customers using AWS database services. This list primarily refers to Amazon RDS, though some features are not available on all services. Focus on business and applications and have AWS take care of the undifferentiated heavy lifting tasks, such as provisioning the database, performing backup and recovery tasks, and managing security patches, storage, and minor version updates. It's a highly available database solution with push-button, synchronous, multiple AZ deployment without having to manually set up and maintain a standby database. Synchronous replication to a standby instance for high availability for Oracle Database Standard Edition 1 or Standard Edition 2. No need to manage backups, and most importantly, point-in-time recoveries of the database. In scaling the instance type up or down on workload patterns without being concerned about licensing and the complexity involved. Here are some of the advantages of hosting database software on EC2 instances. Full control over the database, including sys/system user access and access at the operating system level. And use of commercial software features or options that are not currently supported by AWS. See the online documentation for currently supported options.
The idea behind database services is really pretty simple. Remove much of the day-to-day management and maintenance tasks associated with database administration. Things like backup and high availability, patching, and more can be quite time-consuming. It would be nice to have that time to focus on value-added processes instead. And AWS has a wide variety of options available to fit a lot of use cases. Now that I have a handle on some of the core functionality achieved on AWS, I'd like to learn more about the networking aspects, like how to configure and secure the environment.
AWS has several networking capabilities. Amazon Virtual Private Cloud, or VPC, enables customers to build a virtual network in the AWS cloud. Customers can provision a private, isolated section of the network into which they can deploy resources. Amazon VPC provides advanced security features, such as security groups and network access control lists. AWS networking products work together to meet the needs of your application. For example, Elastic Load Balancing works with Amazon VPC to provide robust networking and security features. Amazon Route 53 is a highly scalable DNS service that routes end users to internet applications by translating human-readable names into numeric IP addresses. Amazon Virtual Private Cloud, or Amazon VPC, enables customers to launch AWS resources into a virtual network that they define. This virtual network closely resembles a traditional network that a customer would operate in their own data center. With VPC, customers have complete control over their virtual network environment, including selection of their own IP address range, creation of subnets, and configuration of route tables and network gateways. A subnet is a range of IP addresses in a VPC. Customers can launch AWS resources into a specified subnet. Public subnets can be used for resources that must be connected to the internet, and a private subnet for resources that won't be connected to the internet. Network traffic entering and exiting each subnet within a VPC can be allowed or denied using another layer of security called network access control lists, which operate at the subnet level. In addition, to secure Amazon EC2 instances running within a VPC, customers can create security groups, which act as virtual firewalls operating at the instance level. There can be up to 5 security groups assigned to an instance. Each instance in a subnet in a VPC could be assigned to a different set of security groups. VPCs automatically come with a default security group. If a customer does not specify a different security group when an instance is launched, AWS associates the default security group within the instance. VPC flow logs capture network flow information for a VPC, subnet, or network interfaces, and store it in the Amazon CloudWatch logs. Flow log data can help customers troubleshoot network issues. For example, to diagnose why specific traffic is not reaching an instance, which might be a result of overly restrictive security group rules. Host-based firewalls are operating system firewalls that customers may enable on their own. These include built-in operating system capabilities, such as IP tables in Windows Firewall, or third-party software that provides additional functionality, such as deep packet inspection or network threat protection. Host-based security software works well with highly distributed and scalable application architectures because network packet inspection is distributed across the entire software fleet.
So first I build a VPC, that's my virtual network in the cloud. I assign the VPC an IP address range and configure public and private subnets within the larger network. I can secure the subnets using network ACLs and create another layer of security at the instance level using security groups. Speaking of security, I'd like to learn more about other ways to secure the environment.
Cloud security at AWS is the highest priority. AWS customers benefit from a data center and network architecture built to meet the requirements of the most security-sensitive organizations. Security in the cloud is much like security in on-premises data centers, only without the cost of maintaining facilities and hardware. In addition, security in the cloud is often better than traditional security because it can be easily automated. AWS customers inherit all the best practices of AWS policies, architecture, and operational processes built to satisfy the requirements of our most security-sensitive customers, giving flexibility and agility in security controls. Security is one of the most important concepts to understand when it comes to cloud computing, and AWS takes this very seriously. AWS is designed to help build secure, high-performing, resilient, and efficient infrastructure for applications. AWS offers security, identity, and compliance services to help our customers secure their workloads and applications in the cloud. Data protection is essential to security. AWS provides services that help protect data, accounts, and workloads from unauthorized access. AWS data protection services provide encryption and key management and threat detection that continuously monitors and protects your accounts and workloads. AWS Identity Services enables customers to securely manage identities, resources, and permissions at scale. Network and application protection services enforce fine-grained security policy at network control points across an organization. AWS services help inspect and filter traffic to prevent unauthorized resource access at the host, network, and application level boundaries. AWS identifies threats by continuously monitoring the network activity and account behavior within your cloud environment. AWS provides a comprehensive view of an organization's compliance status and continuously monitors their environment using automated compliance checks based on the AWS best practices and industry standards in the organization. The AWS security, identity, and compliance services are split up into the following categories: AWS Identity and Access Management, or IAM, detection, infrastructure protection, data protection, incident response, and compliance. Each of these categories contains multiple services. Security and compliance is a shared responsibility. AWS is responsible for security of the cloud, which means that AWS is responsible for the security measures that it implements and operates. It is responsible for protecting the global infrastructure that runs all of the services offered in the AWS cloud. The infrastructure is composed of the hardware, software, networking, and facilities that run AWS services. Protecting the infrastructure is our number one priority. AWS is also responsible for the security configurations of its products that are considered to be managed services, such as Amazon RDS. Customers are responsible for security in the cloud, which refers to security measures the customer implements and operates related to the security of customer content and applications that use AWS services. Customers retain control of the security they implement to protect their own content, platform, applications, systems, and networks, just as they would for applications in an on-site data center. As a consulting partner, you can increase quality for customers by creating solutions that address their areas of responsibility in the cloud, such as solutions to handle the management and security of operating systems, networks, and firewall configurations. AWS Identity and Access Management, or IAM, enables you to manage access to AWS services and resources securely. Using IAM, you can create and manage AWS users and groups, and use permissions to allow and deny their access to AWS resources. It offers fine-grained access control to AWS resources, such as limiting specific users to specific resources or actions, or at specific times of day. Multi-factor authentication for highly privileged users. The ability to analyze access, such as easily identifying and refining policies to allow access only to the services being used. Integration with corporate directories to allow federated access to users on identity systems such as Microsoft Active Directory. Finally, AWS environments are continuously audited with certifications from accreditation bodies across geographies and verticals. In the AWS environment, customers can take advantage of automated tools for asset inventory and privileged access reporting. While customers don't communicate their use and configurations to AWS, AWS does communicate its security and control environment relevant to customers. AWS does this by obtaining industry certification and independent third-party attestations, publishing information about the AWS security and control practices in white papers and website content, providing certificates, reports, and other documentation directly to AWS customers under NDA as required. AWS engages with external certifying bodies and independent auditors to provide customers with considerable information regarding the policies, processes, and controls established and operated by AWS. Compliance certifications and attestations are assessed by an independent third-party auditor and result in a certification, audit report, or attestation of compliance. Customers remain responsible for complying with applicable compliance laws and regulations. In some cases, AWS offers functionality such as security features, enablers, and legal agreements such as the AWS Data Processing Agreement and Business Associate Addendum to support customer compliance. For more information, visit aws.amazon.com/compliance.
It's reassuring to know how much emphasis AWS places on cloud security. It's also good to share with customers which security aspects they're responsible for and which aspects are covered by AWS. AWS handles the infrastructure piece and their managed services, while customers are responsible for securing the data and resources that they build in the cloud. AWS gives them the tools they need to meet that end, but it's up to them to implement. AWS IAM, for example, will help them secure their AWS services and resources. Also, if customers have compliance questions, AWS will provide guidance on how they can achieve them. I guess my next question is, how do you put this all together?
All right, now I feel much more confident talking to my customer about the cloud, cloud computing, and the benefits of using AWS cloud. I can talk to them about the different product categories like compute, storage, networking, security, and management, and the foundational services and features that fall into these categories. But how do I talk about integrating these services together into a solution that's right for my customer and his business needs?
In the previous module, you learned about the benefits of the AWS cloud and some of the core services which help customers realize those benefits. In this module, you'll learn about how to combine those services towards solving customer business challenges. Shown here are just some of the types of solutions possible with AWS. Enterprise applications. Build with a mature set of services specifically designed for the unique security, compliance, privacy, and governance requirements of large organizations. Storage. Durable, cost-effective options for backup, disaster recovery, and data archiving at petabyte scale. Serverless computing. Build and run applications and services without thinking about servers. Windows workloads. Flexible, scalable compute capacity for Microsoft applications. Easily manage and secure Windows workloads. Containers. Package and deploy applications that are lightweight and provide a consistent portable software environment for applications to easily run and scale anywhere. Machine learning. Build with powerful services and platforms and the broadest machine learning framework support anywhere. Internet of Things, a system of ubiquitous devices connecting the physical world to the cloud. Analytics and data lakes. Securely store, categorize, and analyze all your data in one centralized repository. An AWS solution may combine several services and features required to solve a business challenge. Shown here is an example of an architectural diagram of how a solution design might appear. A diagram such as this is designed to show all the services involved, along with the infrastructure being built around them. Take a look at the highlights of this diagram, and we'll revisit the details at the end of this module. Each icon represents a different service or feature of AWS. For example, these icons represent multiple EC2 instances. These represent Amazon RDS database instances. And this represents Amazon S3. This diagram also indicates which AWS resources are being hosted in which availability zone, and which resources are supported by autoscaling and elastic load balancers. Learning how to read and create diagrams such as this is a key aspect of solution design. After learning more about what comprises a sound solution design, we'll revisit this diagram and present more detail.
Hi, this is Maria.
Hey Maria, it's Lee from Any Company Apparel. Nice to meet you.
Oh, hi, Lee. Nice to meet you too. Thanks for calling. Let's get started. Would you mind taking a minute to tell me about your solution?
Not at all. So, Any Company Apparel is a large online clothing seller. We've been in business for about 8 years now and have experienced steady growth since the beginning. About 2 months ago, we acquired a small company, Example Corp Gear. They make unique customer t-shirts and hoodies. Their customers can design their own, or they offer artist services to help with design. They have a lot of musician and theater group clients. I'm the regional IT director, so I absorb their infrastructure. Their site does some neat things, and we plan to keep it as is for the time being. But we need to make it a lot more robust.
Sounds like a great line of work. What kinds of issues are you running into?
As I said, the functionality is pretty good. It just hasn't been performing well recently. During certain hours, it's really slow to respond to users.
Why do you think that is?
Well, they had a contractor design the app and the infrastructure, and he did a fine job, but it's running in-house on just 2 or 3 servers. It was more than enough to start the site, but now, not so much.
I get it. Why not just add more resources?
Actually, they were in the process of looking at that when we came in. Once I did an audit of the site, I started noticing some other things as well. For example, Any Company Apparel's credit card system is PCI compliant. While their infrastructure is pretty secure, it's not compliant yet, and more work needs to be done to get there as well. Also, now that my team is involved, it just doesn't make sense to rely on a contractor.
Makes sense to me. Are there any other issues?
Actually, yeah. We didn't gain any IT staff in the acquisition. So we're also hoping that once everything's in place, we want it to be a pretty low-touch environment, at least from a day-to-day perspective. That will allow us to focus our energy on implementing new functionality as well.
I understand completely. If you don't mind, could you send me some detail on the applications in question? Once I have that, I can start working on a proposed solution for you. I'll be in touch when I have something to share, and then we can schedule a meeting.
Sounds great. Thanks, Maria. I look forward to hearing from you. Bye.
Goodbye.
Shown here is the current architecture that Any Company Apparel is targeting for migration. It's an e-commerce web application which was developed in Java and is monolithic. It's a 2-tier solution, meaning a separate web and database tier. The web front-end and application are deployed to a pair of load-balanced web app servers. The web app servers are running Apache Web Server on an Ubuntu Linux distribution. They are running in a public subnet accessed by customers through a firewall with ports 80 and 443 open. The database is MySQL, running on a single server with no redundancy. It is located in a private subnet behind a firewall, which only allows traffic on port 3306 from the web app server via a hard-coded IP address rule. The database is backed up via a weekly full backup and a nightly incremental backup to tape using commercial tape backup software.
I've seen the customer's current architecture, and I have a solid understanding of the customer's challenges. I have a pretty good idea of which services and features would address those challenges, but I should do some more research. I'd like to put something amazing in front of the customer, something that covers all the bases: security, availability, cost optimization. What are some of the common approaches to this type of migration? And what are the best practices? I'd also like to see if I can share any other customer stories to help build the customer's confidence in what I'm proposing.
The 7 common approaches to migrating architectures to the cloud are rehost, replatform, relocate, refactor, retire, retain, and repurchase. The first 4 involve migrating workloads to the AWS cloud. The others represent other options available to address current on-premises architectures. The next few slides will cover them in detail. For customers starting with an application hosted on-premises, the most common approach is to rehost, lifting and shifting an application to the cloud. Look at this as a like-for-like transfer of application resources from an on-premises data center to the AWS cloud. Servers are migrated to EC2 instances. Network configurations are recreated using VPCs, subnets, security groups, internet and VPN gateways, etc. This is a functional recreation of the on-premises network, only hosted on AWS. The customer benefits from the pay-as-you-go model and can rapidly deploy more resources as needed. Significant cost savings can be realized, even by something as simple as only running test and reporting servers during certain times. Rehosting can be automated with tools such as AWS Application Migration Service, although some customers may prefer to do this manually as they learn how to apply their legacy systems to the new cloud platform. Another benefit to this approach is that it's easier to optimize and re-architect applications after they've been migrated to the cloud. Relocating is the same as rehosting, but it happens at the hypervisor level. This migration moves infrastructure to the cloud without purchasing new hardware, rewriting applications, or modifying existing operations. However, the scenario is specific to VMware Cloud on AWS. VMware Cloud on AWS supports virtual machine compatibility and workload portability between an on-premises environment and AWS. The VMware Cloud Foundation technologies can be used from on-premises data centers when migrating infrastructure to VMware Cloud on AWS. An example of relocating is migrating the hypervisor hosting an Oracle database to VMware Cloud on AWS. Replatforming is similar to rehosting, in that the core architecture of the application isn't being changed. It's about making targeted cloud optimizations, such as switching to a managed solution like RDS, or migrating your application to a fully managed platform like Amazon Elastic Beanstalk. It can also involve optimization of the infrastructure using architectural best practices to go from a functional application to a secure, resilient, and cost-effective one. Refactoring means reimagining how the application is architected and developed, typically using cloud-native features. This is driven by a strong business need to add features, scale, or performance that would otherwise be difficult to achieve in the application's existing environment. Examples of this include changing a database structure from an EC2 hosted database or a standard RDS database to Amazon Aurora, or changing a monolithic application architecture to a more service-oriented design to make use of modern technologies such as containers or serverless like AWS Lambda. You will learn more about application modernization later in the course. Here are some additional strategies to be considered when assessing a migration. Often, a detailed look of a customer's architecture uncovers applications that are no longer useful. Some of them can be simply shut off, reducing the amount of architecture to migrate, maintain, and secure. There also may be certain applications that the customer is unready to migrate for any number of reasons, technical or financial, such as a recently upgraded application. Customers should only migrate what makes sense for their business. There are many compelling cloud-based application platforms. Customers may choose software as a service or SaaS when they want to get zero maintenance and the product provides modern connectivity to data, cloud processing, and other line of business apps. Salesforce is successful because it can offer a fundamentally better CRM than on-premises applications.
Thinking about the size and complexity of the workload, my initial take on this would be a re-platform and migrate some functionality as is, and consider optimizing other components of the architecture, such as swapping in Amazon RDS for the back-end databases to improve their resiliency. I'll need to do some more research to work out the details.
Shown here are some key principles to consider when designing a solution that follows architectural best practices. Design for failure and nothing fails. Assume everything fails and design backwards. Design the architecture so that there are no single points of failure. Use multiple instances instead of one. Leverage multiple availability zones for your applications to provide robust availability. Separate a single server into multiple tiered applications, where each server performs a single function, such as a separate web host and database server. If using Amazon RDS, use the multi-AZ feature. Build security in every layer. Enable data encryption for data at rest and in transit. Enforce the principle of least privilege in IAM, so that no individual or service has more privileges than they absolutely require. Create a robust firewall by implementing both security groups and network access control lists for your entities. Also consider advanced security features and services, such as Amazon Inspector, Amazon Guard Duty, and AWS Shield. Leverage different storage options. When it comes to storage, one size does not fit all. For example, instead of hosting all your web content using web host EBS volumes, consider moving static web assets to Amazon S3. This will also enable the ability to use Amazon CloudFront to allow for global scaling of your static web content. You can also offload web session state from your host to a separate NoSQL database, such as Amazon DynamoDB. This will allow you to scale up and down without losing session information when this horizontal scaling happens. This also makes your web tier stateless for easier scaling. Finally, you can use Elasticache to store common database query results, which will decrease the load on the database tier. Implement elasticity. Implement auto-scaling policies with your specific application access patterns in mind. Architect resiliency to reboot and relaunch. When an instance launches, it should ask, who am I and what is my role? Leverage highly scalable managed services such as S3 and DynamoDB. Think parallel. Scale horizontally, not vertically, meaning add more compute resources to your application rather than adding more power to your compute resources. Decouple compute from state and session data to help with scaling and availability. Use elastic load balancers to distribute the load. Right-size your infrastructure to your workload to get the best balance between cost and performance. Loose coupling sets you free. When services are loosely coupled, they can scale and be made fault-tolerant independently of each other. The looser the services are coupled, the larger they can scale. Instead of a single ordered workflow, use multiple queues. AWS has a number of services that can solve key functionality areas in your application. Take advantage of pre-built services instead of writing mini-services yourself. These can help you with email, queues, transcoding, search, database, and monitoring and metrics. Don't fear constraints. Rethink traditional architecture constraints. If you need more RAM, a traditional solution is to install more RAM into the application server. Instead, consider distributing load across a number of commodity instances. If you need more input-output operations per second, or IOPS, for a database, a traditional solution is to painstakingly rework a schema to increase IOPS. Again, consider scaling horizontally by spreading the load around. Consider creating a read replica for your database and modifying your application to separate database reads from writes. Imagine that hardware failed or a configuration got corrupted. Rather than wasting valuable time and resources diagnosing problems and replacing components, favor a rip and replace approach. Simply decommission the entire component and spin up a fully functional replacement. A critical resource to help you design solutions following best practices is the AWS Well-Architected Framework. It is designed to help customers build the most secure, high-performing, resilient, efficient, and sustainable infrastructure possible in a cloud-native way. It was constructed by reviewing thousands of customers' architectures on AWS. The framework provides a consistent approach for evaluating architectures and implementing designs through a set of questions across 6 pillars, with the design principles that scale with your needs over time. Additionally, there is a well-architected tool available in the AWS console. It helps customers review the state of your workloads and compares them to the latest AWS architectural best practices. It will be covered in more depth later in the course. The framework is divided into 6 areas of focus, referred to as the pillars of the well-architected framework. The operational excellence pillar focuses on running and monitoring systems to deliver business value and continually improving processes and procedures. Key topics include managing and automating changes, responding to events, and defining standards to successfully manage daily operations. The security pillar focuses on protecting information and systems. Key topics include confidentiality and integrity of data, identifying and managing who can do what with privilege management, protecting systems, and establishing controls to detect security events. The reliability pillar focuses on the ability to prevent and quickly recover from failures to meet business and customer demand. Key topics include foundational elements around setup, cross-project requirements, recovery planning, and how we handle change. The performance efficiency pillar focuses on using IT and computing resources efficiently. Key topics include selecting the right resource types and sizes based on workload requirements, monitoring performance, and making informed decisions to maintain efficiency as business needs evolve. Cost optimization focuses on avoiding unneeded costs. Key topics include understanding and controlling where money is being spent, selecting the most appropriate and right number of resource types, analyzing spend over time, and scaling to meet business needs without overspending. The sustainability pillar focuses on minimizing the environmental impacts of running cloud workloads. Key topics include a shared responsibility model for sustainability, understanding impact, and maximizing utilization to minimize required resources and reduce downstream impacts. Migrating to the cloud is a process.
You don't snap your fingers and have everything magically hosted in AWS. Migrating applications takes effort, and a successful cloud migration requires expertise. Fortunately, many people have successfully migrated to AWS, and a lot of knowledge about the process has been captured and shared. Different types of people bring different perspectives to the table for a migration. You want to harness those different perspectives and make sure that everyone has the same focus. You also want to ensure that you have the right talent to help support your migration. HR will need to hire at the correct rate to enable your migration. This can be a lot to track, and someone new to the cloud might not think of all the different people who need to be involved. The AWS Professional Services team created the AWS Cloud Adoption Framework, or AWS CAF, to help you manage this process. The AWS CAF provides advice to organizations to enable a smooth migration to AWS. At the highest level, the AWS CAF organizes guidance into 6 areas of focus called perspectives. Each perspective addresses distinct responsibilities. The planning processes help the right people across the organization prepare for the changes ahead. The perspectives are grouped by capabilities. The business, people, and governance perspectives make up the business capabilities. The technical capabilities are the platform, security, and operations perspectives. The business perspective ensures IT aligns with business needs and IT investments linked to key business results. Using the business perspective to create a strong business case for cloud adoption and prioritize cloud adoption initiatives. Ensure business strategies and goals align with IT strategies and goals. Some common roles in the business perspective include business managers, finance managers, budget owners, and strategy stakeholders. The people perspective supports development of an organization-wide change management strategy for successful cloud adoption. Use the people perspective to evaluate organizational structures and roles, new skill and process requirements, and identify gaps. This helps prioritize training, staffing, and organizational changes. Common roles in the people perspective are human resources, staffing, and people managers. The governance perspective focuses on the skills and processes to align IT strategy with business strategy. This ensures the business values are maximized and risks are minimized. Use the governance perspective to understand how to update the staff skills and processes necessary to ensure business governance in the cloud. Manage and measure cloud investments to evaluate business outcomes. Some common roles in the governance perspective are Chief Information Officer, Program Managers, Enterprise Architects, Business Analysts, and Portfolio Managers. The platform perspectives include principles and patterns for implementing new solutions in the cloud and migrating on-premises workloads to the cloud. Use a variety of architectural models to understand and communicate the structure of IT systems and their relationships. Describe the architecture of the target state environment in detail. Common roles in the platform perspective include Chief Technology Officer, IT Managers, and Solutions Architects. The security perspective ensures an organization meets security objectives for visibility, auditability, control, and agility. Use the AWS CAF to structure the selection and implementation of security controls that meet the organization's needs. Some common roles in the security perspective include Chief Information Security Officer, CISO, IT Security Managers, and IT Security Analysts. The operations perspective helps to enable, run, use, operate, and recover IT workloads to the level agreed on with business stakeholders. Define how day-to-day, quarter-to-quarter, and year-to-year business is conducted. Align with and support the operations of the business. The AWS CAF helps stakeholders define current operating procedures and identify the process changes and training needed to implement successful cloud adoption. Common roles in the operations perspective are IT Operations Managers and IT Support Managers. Each perspective uncovers gaps in skills and processes, which are then recorded as inputs. The inputs are then used as the basis for creating an AWS Cloud Adoption Framework action plan. The action plan is used to guide an organization's change management on their journey to the cloud. Having an action plan that makes sense for an organization can help keep them on track toward achieving their desired outcomes. Migrating to the cloud can be complicated, but you're not alone in this. You have access to many resources that can help you get started, and the AWS Cloud Adoption Framework is a helpful place to look.
Take a look at the benefits of employing customer use cases. As an IT professional, it can be pretty straightforward to create something on paper that follows certain rules to produce predictable results. Production environments often require unique twists, requiring minor alterations from model architectures. Reading about the solutions built around these unique aspects can help fine-tune a design to accommodate these differences. When it comes to presenting a solution, use cases have an important place. No matter how solid the design and underlying infrastructure, a cloud migration often represents a major operational change to a customer. It'll often require more than presenting architectural drawings and service-level agreements to ease their concerns. Showing 4 nines is less compelling than showing actual testimony from a similar customer of how 4 nines solved a business problem, or directly related to additional business value. AWS Customer Success is a key resource for finding use cases to help inspire solution design and build confidence with customers. It features cases from customers from a wide variety of types, sizes, and solution areas. Open the website shown here, and scroll down to where you can search for a customer story. For example, in Maria's case, she may want to look at customers similar to her own. So clear all the filters, then expand a list of use cases to narrow the list by technologies. Expand industries to see case studies in similar sectors. Select retail. Here's a use case specifically in the fashion industry, so select that one. Up top is a quote directly from a customer about how AWS has positively impacted their business. Scroll down further to find architectural details of this implementation. AWS solutions are built using services from AWS. They are designed to help solve customer problems and build faster.
All AWS solutions are vetted by AWS architects and are designed to be operationally effective, reliable, secure, and cost-effective. Every AWS solution comes with detailed architecture, a deployment guide, and instructions for both automated and manual deployment. When applicable, AWS solutions fully integrate APN partner offerings to ensure the most complete solution is offered to the customer. AWS Solution Space provides AWS competency partners a way to exhibit their expertise. These partner solutions include solution briefs, AWS Quick Starts, and Solution Space consulting offers. AWS Quick Starts are another resource designed to help fine-tune and accelerate a design solution. Quick Starts are built by AWS Solutions architects and partners to help customers deploy popular technologies on AWS, based on AWS best practices for security and high availability. These accelerators reduce hundreds of manual procedures into just a few steps, so you can build your production environments quickly and start using it immediately. Each Quick Start includes AWS CloudFormation templates that automate the deployment, and a guide that discusses the architecture and provides step-by-step deployment instructions. Connect to the website shown here. Notice the variety of use cases available on the left. Something Maria may want to research is PCI compliance, so select the security, identity, and compliance use case, and search for PCI. Here is a specific Quick Start just for PCI DSS compliance. Click on it. There is a wealth of information on this Quick Start, including a deployment guide. Scroll down to find additional architectural details on this deployment. Architecture, a deployment guide, and AWS solutions are built using services from AWS. They are designed to help customers solve common problems and build faster. All AWS solutions are vetted by AWS architects and are designed to be operationally effective, reliable, secure, and cost-effective. Every AWS solution comes with detailed architecture, a deployment guide, and instructions for both automated and manual deployment. When applicable, AWS solutions fully integrate APN partner offerings to ensure the most complete solution is offered to the customer. AWS Solution Space provides AWS competency partners a way to exhibit their expertise. These partner solutions include solution briefs, AWS Quick Starts, and Solution Space consulting offers. AWS Quick Starts are another resource designed to help fine-tune and accelerate a design solution. Quick Starts are built by AWS Solutions architects and partners to help customers deploy popular technologies on AWS, based on AWS best practices for security and high availability. These accelerators reduce hundreds of manual procedures into just a few steps, so you can build your production environments quickly and start using it immediately. Each Quick Start includes AWS CloudFormation templates that automate the deployment, and a guide that discusses the architecture and provides step-by-step deployment instructions. Connect to the website shown here. Notice the variety of use cases available on the left. Something Maria may want to research is PCI compliance, so select the security, identity, and compliance use case, and search for PCI. Here is a specific Quick Start just for PCI DSS compliance. Click on it. There is a wealth of information on this Quick Start, including a deployment guide. Scroll down to find additional architectural details on this deployment.
Okay, I just completed my research. I worked together with a colleague of mine who is a professional services consultant, and we came up with a solution designed for our customer. It directly addresses their business challenges while being secure, cost-efficient, scalable, and compliant.
Here is another look at the current AnyCompany architecture. It's a two-tier solution, with one tier running both the web and e-commerce application on two load balance servers, and the other tier a single database server. The web tier allows access to customers on web ports, and the database tier is in a private subnet accessible from the web tier through the database ports. The database performs nightly backups to tape. The proposed solution will support AWS best practices aligned to the well-architected framework and will be secure, resilient, and highly available. It features the following. The original two-tier application has evolved into a three-tier application, and the database functionality is being migrated to Amazon RDS using the MySQL engine. This will greatly reduce the management overhead of the database and will provide automatic failover and backup to S3. Bastion hosts have been added as well. A Bastion host is a host dedicated to managing the production hosts. It will become a single point of management of all the instances. To address the scaling concerns, both the web and application tiers are using the elastic load balancing and auto-scaling features. Instances will be added and removed based upon the load at any given time. Additionally, S3 will be deployed to host static web content,
which can be served via Amazon CloudFront for a more robust customer experience across geographical locations. Application availability has been achieved not only through autoscaling, but by having every tier use 2 availability zones. This includes having a MySQL replica. Another major concern is security. This has been addressed in several ways. In the application, only the web hosts are in a public subnet. The application and RDS instances are in private subnets. Security groups are configured with the following rules. The web hosts will allow internet traffic on 80 and 443 for web requests. Application hosts will only allow application port traffic connections from the web hosts. The RDS instances will only allow database connections from port 3306 from the application hosts. Bastion hosts will allow management connections only from any company's internal network, and all other hosts will only allow management connections from the Bastion hosts. Network ACLs will filter traffic into subnets as an additional layer of network security. S3 buckets will be implemented with the security features enabled. And standard IAM policies with associated groups and roles configured along the principles of least privilege. In addition, monitoring and logging, alerts and notifications for critical events will be configured.
I feel very confident in the solution I'm about to present to my customer. What I need now are some pointers about how to deliver an effective presentation. What are the best practices? How do I respond to their objections? Are there different approaches for different kinds of meetings?
The goal of discovery is to understand the customer's business challenges. Preparing for discovery with your customer is crucial so that you're able to dive deep and ask quality, open-ended questions. Some important steps include: research your customer's business. Familiarize yourself with their business model, vision and mission statements, products and services, and leadership team or key stakeholders. Even diving into their history and researching any community involvement, philanthropic missions, or awards can be helpful to building your understanding of your customer and what is important to them. Background information can also be used to establish credibility and common ground. Determine the market segment. Identify unique laws or regulations that might be factors in creating a solution for them. For example, customers in the healthcare industry often have to comply with laws regarding protected health information, whereas government customers have very specific security and compliance regulations. Identify industry trends that might be drivers for your customers as well. Identify your customers' competitors. What is the competition doing that is providing them a competitive advantage or disadvantage? Is competition driving your customer? What might be holding them back? Research recent news that may have an impact on your customer's business, market, or industry. This might be recent news headlines about your customer themselves, but also could be news about their competitors. Political news like security breaches, new trade agreements, or elections may directly or indirectly impact your customer's business in ways they may or may not have already considered. Research your customer's relationship with AWS. Are they currently leveraging AWS, and if so, how? How long have they been a customer? Who are their account representatives? Maybe you can reach out to them and get some key information. What is their current state of cloud adoption? Which products or services are they using? Can any of their current services be integrated with new ones to form a solution? This can help you understand their level of knowledge about AWS so you can adjust your questions accordingly. Investing time in discovery preparation will help you feel more confident walking into the meeting and will inspire ideas for questions you can ask. While you may be eager to demonstrate all your knowledge of AWS services in the value proposition, the discovery meeting is about listening and understanding, not presenting. Instead, use all of your knowledge to encourage meaningful dialogue about their goals and pain points. Ask targeted questions that will inspire ideas for when it's time to brainstorm solutions. Also, be sure to ask open-ended questions. That means asking questions that elicit more than a yes or no response. Open-ended questions are important because they keep the conversation progressing and provide you with helpful details. Here's an example of a close-ended question. Are you having issues with your current IT infrastructure? A better question would be, what kinds of issues are you running into? The 5 Whys is a conversational tool for discovery to help you dive deeper and find root causes, drivers, and desired outcomes. This does not mean simply repeating the question why after every response your customer gives. And it does not always have to be exactly 5. Asking why helps your customer transition from broad and general statements down to the specifics. The goal is to uncover the real desired outcomes, which may not necessarily turn out to be the same as the ones initially stated. For example, a customer may express a general desire to increase the performance of an application. Ask why it is performing slowly. They might answer it's because of an increased demand. Ask why they haven't increased the capacity to meet the demand. And they might point to a lengthy and expensive process for procuring resources, and so on. Whiteboarding in the context of discovery is a way to keep track of the conversation by writing or drawing out key points so that you can confirm that you have correctly captured what your customer is communicating. Use a whiteboard or other drawing tool to summarize the meeting by documenting things like top pain points, goals, and next steps. Whiteboarding can also illustrate customer workflows and ideation. Listen and design on your customer's behalf. Before the discovery meeting ends, be sure to set expectations for next steps. Let the customer know what you will do with the information you collected and when they can expect to hear from you again.
In the next video,
take another look at Maria's discovery meeting to see how she implements some of these best practices.
Hi, this is Maria.
hey Maria, it's Lee from Any Company Apparel. Nice to meet you.
Oh, hi, Lee. Nice to meet you too. Thanks for calling. Let's get started. Would you mind taking a minute to tell me about your solution?
Not at all. So Any Company Apparel is a large online clothing seller. We've been in business for about 8 years now and have experienced steady growth since the beginning. About 2 months ago, we acquired a small company, Example Corp Gear. They make unique customer t-shirts and hoodies. Their customers can design their own, or they offer artist services to help with design. They have a lot of musician and theater group clients. I'm the regional IT director, so I absorb their infrastructure. Their site does some neat things and we plan to keep it as is for the time being. But we need to make it a lot more robust.
Sounds like a great line of work. What kinds of issues are you running into?
As I said, the functionality is pretty good. It just hasn't been performing well recently. During certain hours, it's really slow to respond to users.
Why do you think that is?
Well, they had a contractor design the app and the infrastructure, and he did a fine job. But it's running in-house on just 2 or 3 servers. It was more than enough to start the site, but now, not so much.
I get it. Why not just add more resources?
Actually, they were in the process of looking at that when we came in. Once I did an audit of the site, I started noticing some other things as well. For example, Any Company Apparel's credit card system is PCI compliant. While their infrastructure is pretty secure, it's not compliant yet, and more work needs to be done to get there as well. Also, now that my team is involved, it just doesn't make sense to rely on a contractor.
Makes sense to me. Are there any other issues?
Actually, yeah. We didn't gain any IT staff in the acquisition. So we're also hoping that once everything's in place, we want it to be a pretty low-touch environment, at least from a day-to-day perspective. That will allow us to focus our energy on implementing new functionality as well.
I understand completely. If you don't mind, could you send me some detail on the applications in question? Once I have that, I can start working on a proposed solution for you. I'll be in touch when I have something to share, and then we can schedule a meeting.
Sounds great. Thanks, Maria. I look forward to hearing from you. Bye.
Goodbye.
This was a fairly short meeting, but in it, Maria used some solid techniques to get a sense of her customers' business goals and challenges. She asked for background information to understand the industry and company structure in play. She avoided yes or no questions and encouraged her customer to provide detail about their needs. She asked why, though only twice was necessary to uncover the root of the customer's challenges. Lack of resources exposed another clear need, achieving PCI compliance. She also made sure to encourage the customer to share any additional details, uncovering a goal to limit the amount of day-to-day management. You should expect that your customer will have questions, concerns, or some objections when you present your proposed solutions. They will expect you to address these before moving forward. Objections are not always based on factual data and are often based on perception. Personal experience, research, or anecdotes may lead to an objection. Science suggests that most decisions are made emotionally rather than logically. Address the emotional components of the objection before the logical ones. The technique shown here aims to validate the customer concerns while keeping the conversation going. First, connect with the customer by acknowledging their concern. You don't have to agree with it, but it's important to understand and validate it. This helps the customer feel heard. Next, try to condense the issue to the core concern. Isolate the problem. The more concise the issue is, the easier it is to address. Then, you can continue, taking steps towards resolution. Here's an example conversation showing these techniques. I'm concerned about security because I can't even tell where my servers are hosted.
I understand. It does seem less tangible than being able to walk right up to your equipment. Is there something in particular you're concerned about?
Well, last spring, a former colleague of mine went through a major DDoS attack. I know he spent all night in the server room trying to resolve it.
If you like, I can go over the built-in DDoS protections on AWS and go over some of the advanced services and features, plus discuss remote access.
Here are some best practices for addressing objections to customers. Use a data-driven approach to support your responses. Provide metrics and data as hard evidence to bring credibility to your claims. Have a few customer case studies prepared to share with customers. Hearing about other customers that successfully implemented similar solutions using AWS can be persuasive and comforting to your customers. Diving deep will help you uncover the root causes for concerns and get to the bottom of the objection. Remember that every question or objection stems from a root concern, so you should uncover that concern rather than memorize generic responses. Your response should be tailored to their concerns in business. Your research in the discovery phase will help you prepare. Have backbone when it comes to defending a solution you've proposed. This does not mean getting defensive with your customer. Rather, have confidence in your responses and leverage supporting materials to strengthen your position. If you are not sure of the correct information right away, assure them you will find the information and get back to them quickly. And finally, keep the momentum going. Don't let a few questions or objections derail your interaction. Objections are a natural part of the process and indicate customer interest. Address them as best as you can and keep the conversation going. Here are some sample responses to common objections. Security. Undoubtedly, your organization has invested in building multiple layers of security and maintaining compliance to global, regional, and national standards. Security at AWS is our top priority too. When you migrate workloads to AWS, you can achieve a higher security posture than in your legacy environment, with greater agility. As an AWS customer, regardless of your size or investment, you inherit all the benefits of our experience, tested against the strictest of third-party assurance frameworks. Cost or cost savings. Reducing the total cost of ownership is a key benefit most organizations seek when migrating to the cloud. With AWS, you can achieve continuously optimized and predictable spend. You no longer have to over-provision infrastructure to ensure that you have enough capacity to handle your business operations during peak demand. Instead, you can provision only the amount of resources that you actually need, knowing you can instantly scale up or down as your business changes. When GE Oil and Gas migrated a significant portion of its applications to AWS, the company decreased TCO by 52%. Scalability and response. When migrating to AWS, you need the freedom and agility to innovate, while also enforcing controls to protect against risk. Start with building your Cloud Foundation team, a small group responsible for catalyzing your migration. Charge the team to create guardrails around security, availability, reliability, and compliance. With AWS Control Tower, you can set up these guardrails quickly and easily. Control Tower automates the setup of a baseline environment for running secure and scalable workloads in AWS. This gives you maximum control without sacrificing speed and agility. Here are keys to consistent results. Preparing for a customer meeting, regardless of the stage in the sales process, is essential. Delivering just 1 hour of content requires approximately 3 hours of preparation. For each of the services you are including in your proposed architecture, you should familiarize yourself with all related acronyms, frequently asked questions, pricing models, and service documentation, including limitations. This information can be found in the FAQ section of each service page. Do your research and anticipate the adaptive nature of customer conversations. Be prepared to address questions, concerns, and possible objections. Every customer interaction is a critical opportunity to differentiate yourself in AWS. Stay on message and don't lose sight of your goals for the meeting. Do not let questions and objections throw you off course. Address them appropriately and confidently and navigate back to your key message. Here are a few things that you should avoid when meeting with your customers. Avoid using words like definitely, never, or guaranteed. Every customer situation is unique and you do not want to overpromise. Watch out for acronyms or technical jargon. Don't assume that they're aware of AWS or even industry acronyms, unless you've heard them use the terms themselves. When in doubt, spell it out. Do not focus on technology, especially in early meetings. Meetings should be customer-centric and focused on their business goals and pain points. Spend more time listening and understanding than talking. Do not focus on solutions for short or midterm future. When preparing a solution for your customers, you should focus on what will provide the best long-term and sustainable results. Do not sacrifice long-term success for short-term wins. When delivering a presentation to your customer, do not read directly from your slides. Use visuals to augment your spoken content and maintain eye contact with your customer, not the screen.
First of all, thanks for sending me the details about the application. My colleagues and I did some research, looked at some similar case studies, and measured it all against AWS best practices. I think you'll see what we're proposing will address your business challenges very clearly. I sent you the proposal earlier, but I'd like to walk you through it now myself.
Sounds good. Let's see it.
First, I want to outline your current architecture so we can better see where we've made some refinements. Currently, you have a web server tier that's also running the e-commerce application. There are 2 servers configured for load balancing. You have a MySQL server running underneath that behind a firewall, performing nightly backup to tape. Does that pretty much sum it up?
It does.
The first alteration we are making is splitting the web and application server into separate tiers. Each of those tiers will run a minimum of 2 servers for high availability. Additionally, they will be placed in separate availability zones, which will provide exceptional uptime over a wide variety of failure scenarios. For scalability, each of these tiers will run in a separate autoscaling group, scaling in or out independently, depending upon the demand of the application. Underneath it all is your database. We're proposing a switch to Amazon RDS for MySQL. This will provide a more hands-off database management workflow, handling the patching, maintenance, availability, and recovery with far less user intervention. We'll also run the RDS instances in separate availability zones for increased uptime. We feel this basic architecture will provide outstanding scalability and availability. Are there any questions so far?
Actually, yeah. What's the benefit of splitting the web app tier into 2 tiers?
Let me see if I can clarify the benefits. When we looked at the metrics you sent us, we noticed that the web server experienced a very different spike pattern than the business application. By separating them, we can horizontally scale, meaning add more web hosts as necessary and not necessarily add more application servers. Also, the average load on your host will lend itself well to the commodity level EC2 instances, especially when the tiers are split. This means that during off hours, when you don't need additional host capacity, you'll be running very efficiently from a cost perspective.
Thanks. Sounds great.
Before we move on to security, let's talk storage. Our solution includes Amazon Simple Storage Service, or Amazon S3, and Amazon Relational Database Service, or Amazon RDS. We're picturing 2 uses. 1, to store the database backups. RDS integrates well with S3 for more frequent backups and has much faster recovery than tape. The other use would be to store the static web assets. This is especially useful for an image-heavy site such as yours. This serves to not only decrease the load on your web host, but provide faster access for your customers. If we take advantage of Amazon CloudFront, those static assets can be made available to points of presence all over the world, providing much better access and response time for your global customers. Your scalability and customer experience should be very strong with this design.
It's certainly a lot more robust than what we have today.
Finally, let's talk about security. The details are in the proposal I sent over, but I'll go over the main points here. The first is using security groups to create firewall rules at the instance level, limiting connectivity to what's required for the application to operate. Web hosts can receive web traffic from the internet, application hosts can receive application traffic from web hosts, and databases can receive database traffic from application hosts. We'll also employ network access control lists at the subnet level, which further seal up your hosts by only allowing one-way traffic where only one-way traffic is required. We're adding yet another layer of security by configuring bastion hosts, or jump hosts. These hosts are accessible only through specific IP ranges on your corporate network and are restricted to ports required for management, like SSH. All the production servers will allow only management traffic to come directly from the bastion hosts. This helps to shrink the attack surface on those hosts. The final component, again outlined in the document I sent, is a best practice configuration of your AWS access using AWS Identity and Access Management, or IAM for short. We recommend a design which follows a role-based approach where the principle of least privilege is applied based on a role's required access only, and nothing more. The proposed solution will put in place the foundational building blocks which will help you achieve your PCI compliance goals. Additionally, I'll send you a link to our guide on PCI compliance that will aid you in figuring out what additional controls might be required on the hosts themselves.
Maria, that is very thorough. Thank you. I do have questions. The first one jumps to mind is the idea that we jump from 3 servers in our configuration to 8 servers at a minimum. Honestly, it just looks expensive.
It does look that way when drawn out. One of the things that doesn't come across in a drawing is the size of each of these instances. Each instance in our proposal is sized based upon our understanding of the minimum needs for the application. For example, the bastion hosts are an addition for increased security. This is a net new cost, however, it will help you move closer to your goal of PCI compliance. And your current web app servers are sized for historical peak periods, so they are underutilized most of the time. The EC2 instances we are proposing are much smaller in terms of resources and cost. By scaling these commodity instances in and out according to your demand, your costs are going to be directly tied to the demands being put upon the application. And one more thing. Considering that this is a 24/7 application, you can also realize a savings by going with reserved instances for the baseline set of servers, up to 75%, I believe.
Oh, I'll have to look more closely at how it all costs out. My other question is about RDS. I like the idea of less maintenance, but I think we'll need more control than RDS will give us for this application.
I get that. I know they designed RDS around minimizing undifferentiated heavy lifting, things like patching, storage provisioning, and backups. But that doesn't make it a fit everywhere. Do you know what type of controls you're missing?
Well, when I looked up MySQL for RDS, it didn't appear to support memcached. This is critical to the application.
Okay. Let me look this up. There it is. It's configurable in option groups. Looks straightforward to implement. I'll send you the link.
That's great to hear. I wasn't looking forward to having to reconfigure everything from scratch. Okay, I think that's all the questions I have for the moment. Is there any way for us to dig deeper on this before making a decision?
Usually the next step is for us to build you a proof of concept architecture on AWS. Let you look at that and tinker with a non-production version of your application running on this architecture. Does that sound okay?
It does. What do you need from me?
The next steps are to get the professional services team involved. I'll be happy to coordinate that so we can get things moving as fast as possible.
Great. Maria, thanks for putting this together. I like the thought you and your team put into this. I look forward to hearing from your colleague.
You're welcome, and thanks for taking time to go over this today.
One of the most impactful things we can do for our customers is show them their applications running on our infrastructure. A proof of concept is a small-scale, practical example of the proposed solution that will run the customer's application for a period of time. The customer will evaluate the solution alongside their current production environment and determine the advantages, disadvantages, and what they might want to change. The POC is also an opportunity to educate the customer about AWS tools and technologies. As you design the POC, be sure not to fall into the trap of simply demonstrating AWS services and focus on meeting business requirements. Once the customer agrees to move forward with a proof of concept, take the time to determine what success looks like. Make sure there are clear goals and scope defined for the POC. During the design, be sure to include any modifications which came up during the presentation of the solutions. Depending upon your job role, you may either construct it yourself or hand it off to someone in a more technical role, such as professional services. Before building, collect the following information from the customer to help you construct the POC. Information such as network and security configuration, where the application code is, access to the databases, and any related data. Building a POC requires skills and resources. You will need to learn how to launch and configure services and features which comprise the solution, how to migrate data from an application, and how to properly validate and test the solution. Additionally, you will need the resources to cover the cost of running the POC on your AWS account. The next video will show AWS programs and resources to support you as you prepare to create a POC for your customer. If you are looking for education and training, AWS offers training courses to help you build the skills required to deliver a POC. There are also self-paced labs available, helping you build and test a wide variety of services and features. These options and more can be found on the APN Partner Portal. You will learn about additional resources available to APN partners later in this course. Quick Starts were mentioned earlier in this course as a resource to help you design your solution. In addition to demonstrating best practice designs, Quick Starts are a way to rapidly deploy architectures as well. Each Quick Start launches, configures, and runs the AWS compute, network, storage, and other services required to deploy a specific workload on AWS. They reduce hundreds of manual processes into just a few steps, so you can build your production environments quickly and start using it immediately. See the Quick Start catalog for a complete list of Quick Starts. Check back frequently for updates. We publish new Quick Starts on a regular basis. The Partner Opportunity Acceleration Program, or POA, is designed to help accelerate sales cycles and customer adoption of your solution, and demonstrate your AWS expertise to help earn customer trust. The POA program co-invests with you by providing AWS promotional credits and cash reimbursement for professional services for eligible projects such as POCs and migrations. APM partners must request this benefit prior to the start of the project. The intent is to co-invest with you and help reduce your cost by co-funding a POC or migration up to certain thresholds. To ensure successful delivery, the POA program expects each POC to have a project plan that details the scope and the respective deliverables. AWS will provide project templates for guidance if necessary. All project proposals must follow best practices in accordance with the AWS Well-Architected Framework, and projects over a certain investment level are required to be reviewed by an AWS Partner Solutions Architect, or PSA. Please reach out to your AWS business contact for details on eligibility and guidelines.
My colleague worked with the customer, built the POC, migrated the customer's application and data. We then presented the POC to the customer, walked them through the operation and management and how to test the functionality like load scaling, failover, backup, and recovery. After a couple of weeks of testing and validation, the customer has agreed to move forward with the solution. Next, I need to walk through the migration and implementation steps of this project and see what I can do to help them continue to build their infrastructure to be the best it can be. My customer is pleased with the proof of concept and is ready to move forward with implementation and migration of their data. What can I do to make sure this goes smoothly and that it's compliant with any regulations they need to follow? Once they've migrated and are up and running for a bit, how can I stay engaged with them and help them to continue growing their solutions to improve their business outcomes?
The three-phase migration process is designed to help your organization approach a migration of applications. While each phase is a common component of a successful migration, they are not discrete phases, but an iterative process. AWS provides a comprehensive portfolio of AWS migration tools to simplify and accelerate each step of the three-phase migration process. In the assessment phase, identify your customer's current readiness for operating in the cloud and the potential business outcomes for the migration. During the readiness and planning phase, address gaps in your customer's readiness that were uncovered in the assessment phase. Analyze their environment, create a map of interdependencies, and determine migration strategies, such as rehost or replatform, to build a detailed migration plan with priorities for each application. At this stage, you set up a secure and well-architected multi-account AWS environment called an AWS landing zone. In the migration phase, the focus shifts from the portfolio level to the individual application. Each application is designed, migrated, and validated. Automatically or manually migrate the applications from different source environments, such as physical, virtual, or cloud-based, to AWS. Additionally, you will likely require a one-time migration of a large volume of data to AWS. During migration, you iterate so you can efficiently operate, manage, and optimize workloads in the cloud. Ideally, you build off the foundational expertise you've already developed. If not, use your first few application migrations to develop that foundation to improve and sophisticate your operating model.
When implementing a new solution for your customer, you may want to follow the minimum viable product or MVP concept. It's a great way to encourage the adoption process so that customers see progress from the start, rather than only at the end of a long process. What is MVP or minimum viable product? A minimum viable product is a functional product or solution with just enough features to satisfy customers' requirements at initial adoption, but leaves room for feedback for future product or solution development. Strongly encourage customers during the delivery cycle to filter ideas for new features and capabilities with MVP in mind. Try to avoid big bang solutions that only have value at the end of a product development cycle. Instead, start with something basic and gather feedback to get more complicated. MVP is the difference between getting the value here at the end of the project and getting value at different stages of adoption throughout the project. You may be wondering about the difference between a proof of concept and MVP. The difference is that a POC is more of a quick demo of the solution, whereas MVP is production level. Here's a look at some of the steps involved in typical migrations, depending upon the methodology. Rehosting or lift and shift can be done entirely manually or have much of it automated. Doing it manually involves a manual install, configuration, and deployment of the application components. Once complete, the applications would be validated on AWS. Then production would be transitioned. And finally, full production achieved on AWS. If using automation, migration tools can remove some or all of the steps above. When replatforming or lift, shift, and tinker, the first step is to determine the new target platform for the application. Then the current infrastructure may require some modifications to prepare for migration. Again, migration tools can be employed for a more seamless transition. Refactoring, by nature, requires many more steps. First, the application needs to be redesigned for the target application and infrastructure. Next, develop the code for the target architecture. Then, a full application lifecycle management, or ALM, or a software development lifecycle must be complete, followed by the integration of the target application. Any company's migration would be categorized as a replatform. The core functionality and operation will be the same, but some modifications are being made to meet some of the specifics of their business requirements and goals. Here is a brief overview of their migration. First, the network infrastructure is created by creating a VPC and subnets. Port security is added via security groups and network ACLs. Access to the site is provided by network address translation, or NAT, and internet gateways. The core application functionality is undergoing a replatform. The web app server is being split into separate tiers, a separate web host and application host. And a third new host, the Bastion host, is being added. These will be carefully configured as Amazon machine images, which will be used for autoscaling and load balancing. The MySQL host is being replatformed as Amazon RDS using MySQL. Then, the load balancing and scaling is assembled through the creation and configuration of autoscaling groups and application load balancers. Finally, S3 buckets are configured to be used for static web assets and database backups. As this is being assembled, data and application code will be migrated manually to the web and application instance. The MySQL database can be migrated to RDS using the AWS Database Migration Service. When your customer is ready to go to production on AWS, there are some best practices for initiating the process. It is highly suggested that you reach out to the AWS account team for that customer and let them know that you are ready to initiate a new project. This is an opportunity to get the solutions architect or the technical account manager involved to provide technical assistance if needed. If your customer has any specific regulatory requirements, be sure to ask if there is an implementation checklist that should be leveraged to ensure the solution is compliant. For example, in the case of Maria's customer, she should ask about PCI compliance. You can reach out to the AWS security teams or solution architect for compliance information as well. Remember that, per the AWS shared responsibility model, the customer is responsible for ensuring compliance with specific regulations for their solution, but AWS may provide guidance. Some of this depends upon the customer's AWS support level. For example, if the customer opts for enterprise support, they will have access to a technical account manager who can proactively monitor their environment and assist with optimization. Once a solution has been implemented, it is recommended to run a periodic well-architected review on the workloads. The AWS well-architected tool helps you review the state of your workloads and compares them to the latest AWS architectural best practices. These can be performed by APN partners or the customers themselves. The review will provide architectural guidance, answer a series of questions about the workload, and the tool delivers an action plan with step-by-step guidance on how to build better workloads for the cloud. Review your workloads consistently.
The tool enables you to monitor their overall status and helps you understand potential risks. Use the results that the tool provides to identify next steps for improvement, drive architectural decisions, and bring architecture considerations into the corporate governance process. Identify and implement improvements. Use the AWS well-architected tool to support continuous improvements throughout the workload lifecycle. The tool makes it easy to save point-in-time milestones and track changes to your workload. Whenever you want, initiate a new review process to help ensure your architecture continues to improve over time. The review uses the free AWS well-architected tool, available in the AWS Management Console. First, identify the workload to document. Then, answer a series of questions about your architecture. Then, review your answers against the pillars established by the well-architected framework. Once complete, you can be provided with videos and documentation, a report that summarizes your workload review, and the result of reviews in a single dashboard.
Enterprises looking to modernize technology can save money by using AWS as they build new applications and retire legacy solutions. When customers plan their cloud migration to AWS, their organization can significantly reduce TCO, freeing up resources to focus on the enterprise's core mission and not in managing servers and buildings. Additionally, the hyperscale breadth of services and level of automation in AWS can achieve incremental savings and, over time, significant cost optimization. Deploying enterprise solutions in AWS can help your customers retire expensive legacy infrastructure, reduce costs, gain agility through automation, and free resources to drive innovation, as opposed to focusing on undifferentiated work.
So, what are some of the ways to modernize architectures with AWS? In this section, you will learn about containers, serverless computing, and data lakes and analytics. These are just a few of the many solutions AWS offers. Check the links in the resources section to learn more.
Containers provide a single way to package your application's code, configurations, and dependencies into a single object. Containers share an operating system installed on the server and run as resource-isolated processes, ensuring quick, reliable, and consistent deployments regardless of environment. The AWS Cloud offers infrastructure resources optimized for running containers, as well as a set of orchestration services that make it easy for you to build and run containerized applications in production. What are potential use cases for containers? Containers provide process isolation that makes it easy to break apart and run applications as independent components called microservices. Package batch processing and ETL jobs into containers to start jobs quickly and scale them dynamically in response to demand. Use containers to quickly scale machine learning models for training and inference and run them close to data sources on any platform. Containers let your customers standardize how code is deployed, making it easy to build workflows for applications that run between on-premises and cloud environments. Containers make it easy to package entire applications and move them to the cloud without needing to make any code changes. And containers can be used to build platforms that remove the need for developers to manage infrastructure and standardize how applications are deployed and managed. AWS provides a set of fully managed services that you can use to build and run serverless applications. Serverless applications don't require provisioning, maintaining, and administering servers for backend components such as compute, databases, storage, stream processing, message queuing, and more. There is no longer a need to worry about ensuring application fault tolerance and availability. Instead, AWS handles all of these capabilities. This allows your customers to focus on product innovation while enjoying faster time to market. As a business grows, data accumulates. Inevitably, it gets placed in different silos, making it difficult to access and analyze. Storing data in a single place, or a data lake, can solve this problem. Data lakes help companies optimize operations by making it easy to read data and obtain insights. To build your data lakes and analytics solution, AWS provides the most comprehensive set of services to move, store, and analyze your data. Import your data from on-premises and in real time. Store any type of data securely from gigabytes to exabytes. Analyze your data with the broadest selection of analytic services. Predict future outcomes and prescribe actions for rapid response. Organizations that successfully generate business value from their data will outperform their peers. The ability to harness more data from more sources in less time and empowering users to collaborate and analyze data in different ways leads to better, faster decision-making. Examples where data lakes have added value include improved customer interactions, improved R&D innovation choices, increased operational efficiencies. AWS provides the broadest and most cost-effective set of analytic services that run on the data lake. Each analytic service is purpose-built for a wide range of analytics use cases, such as interactive analysis, big data processing using Apache Spark and Hadoop, data warehousing, real-time analytics, operational analytics, dashboards, visualizations, cataloging, and securing. For interactive analysis, Amazon Athena makes it easy to analyze data directly in S3 and Glacier using standard SQL queries. Athena is serverless, so there is no infrastructure to set up or manage. Customers can start querying data instantly, get results in seconds, and pay only for the queries they run. For big data processing using the Spark and Hadoop frameworks, Amazon EMR provides a managed service that makes it easy, fast, and cost-effective to process vast amounts of data. For data warehousing, Amazon Redshift provides the ability to run complex analytic queries against petabytes of structured data and includes Redshift Spectrum that runs SQL queries directly against exabytes of structured or unstructured data in S3 without the need for unnecessary data movement. For real-time analytics, Amazon Kinesis makes it easy to collect, process, and analyze streaming data such as IoT telemetry data, application logs, and website clickstreams. This enables customers to process and analyze data as it arrives in their data lake and respond in real time instead of having to wait until all of the data is collected before the processing can begin. For operational analytics such as application monitoring, log analytics, and website analytics, the distributed open-source search and analytics suite, Amazon OpenSearch Service, allows customers to search, explore, filter, aggregate, and visualize data in near real time.
Amazon Open Search Service is a successor to Amazon Elasticsearch Service. It delivers OpenSearch's easy-to-use APIs and real-time analytics capabilities alongside the availability, scalability, and security that production workloads require. For dashboards and visualizations, Amazon QuickSight provides customers a fast, cloud-powered business analytics service that makes it easy to build stunning visualizations and rich dashboards that can be accessed from any browser or mobile device. For cataloging and securing data, AWS Lakeformation makes it easier to build, secure, and manage data lakes by simplifying and automating many of the complex manual steps that are usually required to create data lakes. Lakeformation is pointed at the data sources. Then Lakeformation crawls those data sources and moves the data into a new Amazon S3 data lake.
This is great information. For any company, we've got a solid migration plan based around replatforming their current architecture. We're constructing the environment and we'll be migrating the data after that. Once in place, we'll validate the functionality, run the site in parallel with their existing site, then transition to the AWS site. Once they're up and running, I'm going to suggest running a well-architected review. One area of focus will be on total cost of ownership, or TCO, to make sure any company is getting the best value possible from their architecture. Learning about some of the modernization options has put me in a good position to help my new customer. The customer is forecasting large growth for this application. There is a case to be made to start incorporating analytics to improve customer interaction and innovation. I could start by reviewing use cases on how e-commerce customers are building their analytics story with AWS. I could leverage in-house data and analytics expertise while building up my own expertise through training. Eventually, we could construct a POC using data and analytics services to share with the customer. Wow, my first customer! I'm excited about watching their applications succeed and thrive on AWS.
That went well. Still, there's a lot of work to do. Since my company is part of the AWS Partner Network, I want to learn more about APN programs and resources. These tools might help me with my current project and future ones too. How do you think APN programs and resources will help you in your business?
The AWS Partner Network provides significant benefits. For example, partners can leverage the innovation that is developed by AWS, and they have access to tools and resources that help build and architect solutions for themselves or their customers. AWS provides partners a broad reach to expand their addressable market. These are just a few of the reasons partners are encouraged to join the AWS Partner Network. By becoming an APN partner, you can deliver more innovation at a fast pace with a constantly evolving portfolio of AWS technology and services. Access free and reduced cost training to get your team certified on AWS. Market your business and participate in exclusive events such as reInvent or reMars or Reinforce. Or promote and sell your solutions through AWS Marketplace, our digital catalog for AWS customers. Highlight your expertise with APN programs and differentiate your business practice. Define your APN partner journey based on your business focus area and capabilities, and make the most of your investment. Increase visibility to AWS field team and AWS customers, and take advantage of sales opportunities. Save time and money, and get the tools and resources you need to reach customers and respond quickly to their needs. The growing breadth and depth of AWS services, as well as the evolving capabilities and business models of our partners, has led us to introduce Partner Paths, a curated experience for partners to navigate resources, programs, and benefits based on their specific types of customer offerings. This approach moves us away from a partner-type model of consulting and technology to provide partners more flexibility in all the ways they engage with AWS. The simplified experience allows partners to easily navigate to the curated resources, benefits, and programs aligned to their customer offerings. This is therefore an offering-based model. We believe recognizing partners for what they offer customers will help them find the resources they need to serve our customers. The 5 Partner Paths. Software Path. This is a new name for the Independent Software Vendor or ISV Partner Path that was launched in January 2021. This path is for those organizations that has software that runs on or is integrated with AWS and want to be recognized and engaged. You may be wondering about the name change. Partner feedback was that organizations that have software may not consider themselves ISVs. Today we have Global Systems Integrators, GSI, and partners that started in the hardware space launching software solutions. The Hardware Path is for organizations that have hardware devices that work with AWS. Today you would find these partners listed in the device catalog. Services path, which encompasses what we know today as consulting partners. Organizations that deliver consulting, professional, managed, or resale services will find the resources, programs, and benefits they need in the services path. Training path is for organizations that today or in the future want to sell, deliver, or incorporate AWS training. Distribution path. This is an invite-only path to help authorized distributors engage faster with AWS. Partner paths are accessible via a newly redesigned Partner Central experience. Visit Partner Central AWS Partner Paths to review the APN Navigate tracks which guide APN partners step-by-step through the AWS Partner Paths and business requirements. You can also visit AWS Partner Paths and AWS Partner Cast for more details about AWS Partner Paths. Each partner path features 5 stages, which are: registered. This simply means you have accepted APN terms and conditions. Enrolled. Here you will select a path, typically the one that matches the largest share of your offerings. Later on, you can select additional paths. Confirmed. This means you have provided your billing information, so we can bill you the APN fee. The key stage is the validated one. This is where a partner earns the bulk of the benefits. To reach this stage, a partner needs to meet the minimum requirements associated with each path. For the services and training path, this is done by earning select tier. For the software path, it is completing a foundational technical review, or FTR. For the hardware path, we have device qualification, which is basically an equivalent to the FTR on the software path. And differentiated. This is the most advanced stage. Differentiation means partners have taken an extra effort and invested to earn recognition by achieving a competency, a service validation, the MSP program, or the well-architected partner program. Each partner path has the same stages. The actions required to progress down the path vary as you get to validated and differentiated stages. APN Partner Central is the partner-only section of the AWS website. It provides APN partners in all paths with the tools and content they need to grow their business on AWS. Through APN Partner Central, you can access AWS technical and non-technical training, request marketing and business support, download partner-focused content, and connect with other partners around the world. The AWS Partner Resources website also provides links to many tools and content to help grow your business on AWS.
As you're experiencing right now, AWS training and certification helps you deepen your AWS knowledge and skills, differentiate your business from competitors, and better serve your customers. Both digital and classroom training are available, so you can learn best practices online at your own pace or in a classroom setting with an AWS instructor. To get started, choose one of the 3 learning paths. AWS Technical Professional Path will help you gain fundamental technical knowledge about AWS cloud computing. The AWS Business Professional Path will help you gain a basic understanding of AWS services and core business value propositions. And the AWS Professional Services Path will help you develop and extend professional services competencies. The paths are well defined and introduced in more detail next. They are also available online, so you can refer to them throughout your training and certification journey. Here is the AWS Technical Professional Learning Path.
This path, partners start by achieving AWS Partner Accreditation Technical and AWS Partner Cloud Economics Accreditation. This confirms a strong understanding of AWS fundamentals for technical professionals. Then, partners advance to additional training specific to their workload or solution area. Here is the AWS Business Professional Learning Path. On this path, partners start by achieving AWS Partner Accreditation Business and AWS Partner Cloud Economics Accreditation. This confirms a strong understanding of AWS fundamentals for business professionals. Then, partners advance to additional training specific to their workload or solution area. Here is the AWS Professional Services Learning Path. The path is designed for partners in technical roles who develop and extend professional services competencies for AWS customer implementations. Partners can select training by advisory services or solutions. These courses are recommended for APN Premier and Advanced Consulting partners who have achieved the recommended level of AWS certification.
This has been quite a journey so far, and I've learned so much along the way. Things like the AWS Cloud Value Proposition, the core services and functionalities such as networking, EC2, S3, and RDS, applying that functionality towards solving customer business challenges, architectural best practices in the well-architected framework, how to present solutions and collaborate with my customers, proofs of concept, implementing solutions and guiding my customers toward modernization, and APN resources. I'm in a great position to bring value to my customers on their journey to the AWS cloud.